Now, I'm going to turn it over to Jeff for one slide here, as he's going to kind of talk about some of our redundancy throughout the stack.
Thanks, Simon. So one of the things we looked at is, as Simon mentioned, high availability has actually been something we've talked about for many, many years. In fact, one thing I remember telling people is, as much as I love virtualization, virtualization can actually create problems. Single point of failure actually being one of the biggest ones. The fact that you've now taken 10, 20 servers, you've consolidated down, you're running everything on a single server, it means if that single server goes down, you didn't just lose one workload, you lost 10 or 20. So the value of that server has gone up dramatically. Well, in Server 2012, we've literally looked at complete redundancy in the box, all the way from the ground level up. I didn't have a chance to talk about this. I'm not really going to talk about too much right now, but it's something that's brand new in Server 2012 is hardware fault error detection through RAS capabilities. So we can actually detect hardware faults, understand where those hardware faults are occurring, and make sure we don't allocate resources that use any of those. So for example, if we get a memory controller that tells us, hey, by the way, we've got an address of memory that is failing, we can actually it notifies the hypervisor, because Hyper-V knows where all of the pages live, where they're all allocated. Are they in the parent partition? Are they in a VM? Where do they live in that part of the VM? Has it been allocated? Has it been not allocated? And a really good example is, if, for example, we find out, we get notified by a memory controller, guess what? This particular area of memory is gone bad or is going bad, we can notify Hyper-V. Hyper-V then can look at it and go, oh yeah, we can see that, it hasn't been allocated. We can take it offline. We then store this information off in the BCD store so it survives reboots. And in fact, we ensure that this VM or the server actually never allocates this area in memory. So what have we done? We've actually gone to the not only providing you high availability, we've gone so far as to help protect you from errors that haven't even occurred yet. So this is something brand new in Server 2012, and a special kudos to our core kernel team and on our Hyper-V guys working very closely to provide this capability in the box. Then we take it up a level to physical node redundancy. So physical node redundancy is pretty much where Simon's living here, which is where we have failover clustering for unplanned downtime, and we have live migration for planned downtime. So in the case that a server is going to go down, I want that if I yank the power cable out of a server, I want it to be able, all those workloads, to fail over to another system without any sort of restart or any sort of user intervention involved. I want those VMs to automatically restart without any user intervention. Or in the case of planned downtime, I want to be able to live migrate those, perform any sort of maintenance I need to do, and then migrate them back. If we then move up the stack again to I/O redundancy, so we've got redundancy now both at storage and networking. So networking and load balancing and failover via Windows NIC teaming, done in the box. Storage multipath I/O, that's been in the box now. That provides this MPIO for both iSCSI, Fiber Channel, both from a host level as well as a guest level. In addition, we've got multi-channel SMB. So if you're using a file server as the back-end storage, guess what? We've given you redundancy at that level. So let's move up the stack again. Now let's move up to application service and failover. So if you're running VMs and you want to provide a level of failover within the virtual machine, say for example, you're running a cluster-aware application and you want to cluster those applications, great, you can do that. You can run a guest cluster using iSCSI or now the new virtual fiber channel. You can also do guest NIC teaming. So now you get network redundancy for SRIOV NICs within your virtual machine. But we didn't even stop there. What if you have that old legacy application that's not cluster aware? I'm sure you heard this many times on the clustering team, Simon. Someone comes to you and says, look, I've got this thing that we wrote a long time ago. We purchased from another company. They're no longer around. It works, but we know it's got a known memory leak. It needs to be kicked or rebooted every 6 weeks or something like that. Wouldn't it be great if there was some way that we could provide additional resiliency for those types of applications? Well, we did that exactly with app monitoring, which is also in Server 2012, where we can do some light level health monitoring and actually restart or notify you when these types of actions occur. Then we go all the way up to the very top of the stack and we get to disaster recovery. Now we're talking about high availability beyond your single site. High availability can be, yeah, it's 2 servers or it's a cluster of servers and they're failing over, they're migrating, whatever, within a cluster. But what if I want to fail over to another site completely? So we've done some huge changes here, both in cluster shared volumes as well as Hyper-V for asynchronous replication. And we'll get to both of those, and I'm going to pass it back to Symon so we can talk about some of that work that we've done with cluster shared volumes and clustering in Server 2012.
Thanks, Jeff. So what I'm first going to talk about is just provide a real basic overview of what is a failover cluster and what happens during a failover. Because I know some of you are new to this high availability concept, and so we really kind of want to make sure you understand the basics before we move on to some more advanced concepts. Now, the key requirements for a cluster is redundancy, 2 of everything, and the goal here is to eliminate any single point of failure. So in this little scenario I have here, you can see that I have multiple networks connected to my public clients, connected to the other nodes through what we call a heartbeat network, and then connected to my storage area network, my SAN. And so on my first node, my node on the left, we're actually running several different workloads. Now, the way the cluster works is all of the nodes are simultaneously monitoring each other through this heartbeat network. And additionally, every node keeps track of what every other node in the cluster is doing. Under the cluster registry, we basically have what we call the cluster database. In this database, it keeps a detailed list of every single resource in the cluster, so every virtual machine, and then the states of the virtual machine and the properties of the virtual machine. So let's say, for example, node 1 has VM1, VM2, and both of them are online. Node 2, Node 3, Node 64, they're also going to have an accurate copy of those 2 nodes in the cluster and their current state. And the reason for this is if there's a disconnection in the network, or one of our nodes suddenly crashes, all the other nodes already know what that original node was running. So it's easy for them to start up these new virtual machines, VM1 and VM2. So let's take a look at this in the graphic. In this case, my node crashes. And this means that the public cannot connect to the server, and they can't go and then connect to the backend data, such as our VHD files, which are stored on our SAN. Now, after this happens, the other node, it does a health check. It looks at the node that crashed, says, are you unresponsive? Are you unresponsive? Yes, you are. So now I'm going to take failover actions. Now remember, this second node already knew what the original node was hosting. It had all of that information in its database. So the second node will start VM1, it will start VM2, it will connect to the appropriate VHD files that are stored on the network so that those VMs can access their data, and then the clients can connect to those VMs. So this is the basics of a failover. Now there are 2 different types of clustering that we're going to be talking about, host clustering and guest clustering. Now, host clustering is the most common type of clustering, probably what most of you have heard of, what you've played around with, what you're familiar with. And with host clustering, we are basically clustering the physical servers. And then we can move applications or virtual machines between those 2 physical servers. So let's say, for example, I have a a power failure on one of my servers. The other server detects that, it moves the workloads over. Now, additionally, this can eliminate the problem of having a virtual machine crash. So if the VM, the Hyper-V VM itself crashes, the host can detect that the VM is offline and restart that VM. Same thing if a VM hangs. We could detect that it's non-responsive. There's a blue screen. There's a user mode hang. We can go restart that VM again. Now, additionally, when you have a cluster, this gives us the ability to have mobility between the nodes. So if you need to do maintenance, do a live migration, move that VM to another node in the cluster, and then you can do that planned maintenance on that original host. Now, the other type of clustering, which is less commonly used, is known as guest clustering. And this is where we have 2 virtual machines. The virtual machines are running Windows Server, and they form a cluster themselves. And so what this does is it gives us high availability between virtual machines. So for example, let's say I have a SQL server running inside a VM. Well, if I need to patch the operating system of that VM, I could fail over the SQL server to the other node. If that VM crashes, the other node will detect it. It will fail over that SQL server. So this essentially gives us this resiliency inside my guest operating system. Now, one big thing to note with the difference between the physical and the virtual is that when you're working with the physical layer, you do have more options for your storage area network. Again, we have fiber channel, iSCSI, serial attached SCSI, fiber channel over Ethernet, and SMB. However, when you're working inside the virtual layer, we need to have virtualized HBAs or host bus adapters for those VMs to be able to attach to the storage. And so if you have a guest cluster, your storage options are virtualized fiber channel over Ethernet, or iSCSI. So you still have a lot of options, but you do have some limitations. Specifically, you can't use serial attached SCSI for your guest virtual machines. Now, I often get asked, wow, I can get this high availability on the physical layer. I could get high availability on the virtual layer. Can I combine them? Absolutely. This is fully supported, and in fact, this is recommended to give you the best high availability possible. You could combine all of your virtual machines so long as they pass our cluster's best practice analyzer, which is known as Validate, that we're going to cover in a little bit. And you can even mix physical and virtual servers so long as they pass this set of tests. So this gives you the best application availability, best virtual machine availability, and best physical server availability. Now with Windows Server 2012, we made a lot of enhancements in the scale. And we touched on this in our earlier modules, but the key thing here is we are the largest clusters in the industry. We now have 64 node clusters. They can support 8,000 virtual machines across all of these nodes, with up to 1,024 virtual machines on a single node. Now, when you think 8,000 VMs, could you run that on 8 servers, an 8-node cluster? Yeah, you could. Technically, that's supported, but always keep in mind capacity planning. What happens when one of those servers needs to be patched? Well, if you have 1,000 VMs that need to go to 7 other servers that are fully stacked, you're going to be going over the limits here. So always make sure you plan to have reserve capacity so that if you have to do patching, if there's an unplanned failure, when those VMs move around to other nodes in the cluster, they'll still stay online and you'll still be supported. Now let's talk a little bit about failover cluster deployment. Our first thing are these validation tests. Now, back in the day, 2003 clustering, if you did that, yeah, it was kind of a nightmare to set up. You know, you'd have this 50-page white paper, go through step by step, and I'll be honest, my first day on the team, my boss told me to go deploy a 2003 cluster. I spent all day doing it. At the end of the day, I completely failed, couldn't get anything running, and I thought, what the heck am I doing here? What is this product I'm working on? It does not make sense. So this was right around when the beta of Windows Server 2008 came out. So the following day, he did an experiment. He gave me the beta. He actually didn't give me any instructions. He said, just go try deploying this on 2008. Follow the step-by-step troubleshooter, this best practice analyzer, this tool called Validate. I had my cluster up and running in 90 minutes. So if you've tried clustering in the past, try it again. This significantly simplifies the deployment. To go from 8 hours, failure, frustration, to 90-minute success without really any documentation or guidance, wow, I mean, that's really a great success story of just how much better this is.
Let me reiterate and emphasize something you just said, because this is something I run into quite a bit. Someone tells me, hey, you know what, I had some issues with clustering in the past, and you know, I had some trouble, and validation was kind of tricky, and I always ask them, what version of clustering you're talking about? And almost always it's like 2003. Folks, this is another example of, please understand, we made huge improvements in clustering in both 2000 and 2008 R2, and in 2012, you know, the validation process is really simple. And the important thing to understand is, as long as you go through the validation wizard and the validation validates the configuration, it's supported by Microsoft. So that's what really makes it really easy to deploy a cluster, because we provide the tool in the box to do it. So that's a key thing to remember. And again, if you're used to, or if you're thinking about clustering and you think of 2003, throw all that away. This is a completely different and much more mature clustering that's built into Server 2012.
Thanks. Now the second big advantage of this validation test is if you want to have dissimilar hardware. So back in the day, again, 2003, right, if you wanted a cluster, every piece of that cluster had to be listed on our hardware compatibility list, our HCL. So if you wanted to add another node a couple months later, if you needed to replace a NIC a year later, and it didn't match that exact piece that's listed on our compatibility list, no good, wouldn't be supported. So we said, all right, guys, this is costing Microsoft a lot of money, our OEMs a lot of money. Does everything really need to be identical? And we realized that's no longer the case. So you can use completely dissimilar hardware so long as it passes our validation tests. Now, one thing, of course, to keep in mind, if you're using virtualization, you want to make sure that you have the same processor family on all of those hosts. So all Intel, all AMD. And this is so that you can use live migration. Now, we specifically added a set of Hyper-V tests in Windows Server 2012 just for Hyper-V. And that's actually one of the things that we now check for. The tests are much faster, and they have been designed and optimized purely for our Hyper-V deployments. Now, let's actually switch over to my demo, and we're going to take a look at our Hyper-V deployment here. Now, first thing just to show you here, this is 3 physical servers that I have, and these are connected by iSCSI. So I'm using Microsoft iSCSI Target. Nothing special, nothing fancy here. And this is the Failover Cluster Manager graphical user interface. And what we're going to do here is we're going to click Validate a Configuration to launch our validation wizard. So what it's going to do is it's going to ask me, what are the names of the nodes that are going to be part of this cluster? So I'm going to say Symon P, Windows Server 12.1, Symon P, Windows Server 12.2, and Symon P, Windows Server 12.3. And this is basically specifying these are the 3 nodes that I want to test and then use in my cluster. So I have the option to run all of the tests or just a subset. Now in the real world, you're going to want to run all of the tests. It tests your network, your storage, inventory of software, basic configuration, and of course these Hyper-V tests. But for the sake of time, for the sake of the demo, let's just go ahead and take a quick look at these Hyper-V tests. As you can see, we have quite a lot in these other categories. So I'm going to select my Hyper-V tests. I'm going to click Confirm, and boom, my testing is done. And one of the nice things about clustering is we realize that clusters are now used for most mission-critical applications, and a lot of our customers have documentation requirements. And so for this reason, anytime you do an action on a cluster, we're going to automatically generate a report for you and store that on every single node of the cluster. So every validation test, when you create a cluster, you add new resources, we automatically save this information for you. Now we can see my Hyper-V test, everything came back green. Great. Well, let's actually take a look at another validation report. This is one that I ran last night on this exact same cluster, but I was using stale disks. And these disks, basically I took them from a different server. They had some stale reservations on them. And you can see that this is immediately flagged that, hey, there could potentially be a problem if you try to use this in production. So if I click on my storage, I can see some of my tests were failed, some got canceled, some got warnings, and you're able to now drill down and get accurate information about what the exact problem is. So this is also going to save you a lot of time and money on support calls. In the past, you call Microsoft, they would spend a long time troubleshooting the cluster, they would send you tools that you would have to run to inventory everything. Now, first troubleshooting step, run this best practice analyzer, cluster validation. You get detailed information of everything in the cluster, how it's deployed, how it's configured, and you can then go and send that to product support. And in fact, this can eliminate most of the issues before you even need to call product support. And one other thing to mention, you can run this before you deploy your cluster, as part of the cluster deployment, or you can even run this while your cluster is in production. And if you run it in production, it will run additional tests to make sure that you're following best practices, to really try to optimize the cluster for you. So for example, disk failover time is important for us, right? We're high availability, we want to minimize downtime. So depending on what type of online options you have when you bring your disk online, we're going to check whether those are optimized. Does it run a full check disk? Does it run a quick check disk? And so that's just one example of the ways that this test can continue to try to optimize the cluster. Now let's go ahead and click Create a Cluster using these validated nodes. So I just tested everything. It all looks good. And this launches our Create a Cluster wizard. So creating a cluster is literally 2 steps. Step 1, what are the nodes in your cluster? I already entered that from the last wizard. Step 2, what are you going to call this cluster? So let's call this cluster Jumpstart. We'll click Next. We're going to add all eligible storage to my cluster. Now remember, I've already pre-configured my storage, so all of my nodes can go and see my iSCSI targets. And the way we consider eligible storage is we look at the storage that every single node has access to, and then we make a mapping to see what storage all of the nodes can simultaneously see. And we realize this is your storage area network. So for example, it's not going to take local disks on node 1. It's going to take these shared disks across all of your different nodes. Once again, we get another report that gives us the details of everything that happened as part of this configuration. Now our cluster is being created, and so as we kind of browse here, we get some information about the state of the cluster and any events it has. We could take a look at what has been deployed on the cluster, such as virtual machines, and we're going to go ahead and do that shortly. We get to see the nodes that are part of the cluster. We get to see the storage which is attached to the cluster. And so I have 3 disks here that are part of my cluster. And then we can finally see some cluster networks. Now, I'm going to give you guys a little challenge out there. Taking a look at what I have deployed here. What best practice am I not following? Well, I'll let you guys spend some time typing it out, but the answer is I only have a single network here. Take a look at that. Now, this is a bad best practice because I have a single point of failure here in my cluster. I lose this network, I lost all of my cluster communication. My cluster won't be functional. So shame on me, not a best practice. But good for you guys to realize that. Now, next thing I'm going to do here, before I deploy a virtual machine, is I'm going to go and enable what we call cluster shared storage. And Jeff's going to spend a little bit of time later really defining what cluster shared volumes is. But essentially, it's a distributed access file system that's been optimized for Hyper-V. And so what this means is all of the nodes can simultaneously write to a single disk. So I can have a single disk, a virtual machine with its VHD file on that, running on node 1, another VM with its VHD file running on node 2, 3rd, 4th, 5th, and all of these nodes have controlled access to the disk to avoid any type of corruption. Now, converting to this clustered file system, well, technically it's not a clustered file system, but functionally it's the same type of thing, and it's actually what would be equivalent to VMware's VMFS. It's as simple as selecting the disks, saying add to cluster shared volume. And now all of a sudden, these are now cluster shared volumes enabled, and I'm ready to go and deploy my Hyper-V virtual machines on top of this. Now I'm going to go back to the presentation for a little bit, talk briefly more about some deployment options, and then we're going to go ahead and actually deploy and optimize some virtual machines on my cluster. One of the other questions I get asked a lot though, people are so excited about Windows Server 2012, how do I get there? How do I upgrade? Well, there is no direct way to do what we call a rolling upgrade from 2008 R2 to 2012. And what that used to mean in the past was you could have one node of the lower version, connect it to one node of the higher version, and do a failover or a live migration between that. We've made so many improvements with each incremental release that we simply don't have this compatibility. And so what you're going to do if you're upgrading a cluster, you run this built-in utility called the Cluster Migration Wizard. You have your old cluster, so you have your new cluster, you point to your old cluster, it will analyze all the VMs, file servers, other workloads running on it, and you pick which you want to migrate, and it moves them over. So for virtual machines, it's essentially a glorified export-import, which under the covers calls the PowerShell commandlets. But we take it a little further. When we're actually pulling the VM from the old cluster to the new cluster, we take a look at the networks that you had on the old cluster. A private network, external network, internal network, and we map those to the networks you have on your new cluster and give you the option to go and pair them. And the idea here is with a mass migration, we do this once, we remap the networks a single time, and then when the virtual machines are moved over, they should continue to function just like before. So let's talk about Hyper-V optimization as part of our cluster. One of my favorite new features in this release is virtual machine prioritization. We've heard our customers ask for this for 2 releases now, and so finally got it, we're finally bringing this to you. And this gives you the ability to rank your virtual machines: high priority, medium priority, low priority. And then a fourth option, no auto start. We'll touch on what that means shortly. But what this does is it gives you the ability to rank your virtual machines for what are most important. So let's say your cluster's offline. You need to start up 100 virtual machines. Well, what we're going to do is look at the start order, start the high priority ones first. Once they're up, then medium, then low. So this means that you can get your business critical applications up and running first before you then have to worry about the human resources department's virtual machines, so that those less important ones, non-mission critical, are no longer competing for resources. Similarly, you could use this logic to bring up critical infrastructure servers. So again, let's say your infrastructure is offline. First we bring online our domain controllers, maybe our SQL databases, then our application servers, and then finally those other apps which have dependencies before that. Now, we also have the ability to do what we call preemption. And this means that if there's a high priority virtual machine that is unable to start because there's just not enough resources for it, we'll actually shut down a low priority VM to allow that high priority VM to come online. So this way we can always ensure that we have our high priority VMs running, assuming that we still have capacity. Now this auto start feature, option number 4, this gives you the ability to say, this virtual machine, it's just not important. Yes, I virtualized my whole environment. You know, I virtualized the human resources department's document store. Right? Okay, let's be honest, that's not mission critical. I hate to joke so much about human resources. My fiance works in it, so I'm allowed to make fun of them a lot here because they do some crazy inefficient stuff. Now, as part of this, these guys, the file server for the human resources department, basically, it doesn't need to come online. It doesn't need to contend for resources. When our entire IT infrastructure crashes, becomes unavailable, we got to get our important ones up first. So virtual machines that have this setting disabled, they're going to stay offline until someone manually starts them. Again, eliminating this contention for critical resources. Now, a lot of people say, okay, I have 2 virtual machines which I want to have always be on the same host, because maybe there's some functionality where you need efficient networking between those 2 virtual machines. Or let's say you have a particular application which is really resource or network intensive, and you have that one beefy cluster node that you really want that VM to always stay on. Well, we've had this option for a while. It's called preferred owners. And what this will do is, by default, those VMs will always move to a preferred owner. So if VM1 and Node 1 are preferred owners, VM1 will always try to go to Node 1. Now you can have multiple preferred owners. So you have VM1, Node 1, and Node 2. It will go to one of those 2 nodes. So if it's on Node 1, Node 1 fails, it will move over to Node 2. Now then we also have an option for second place owners, which we call our possible owners. So if your preferred owner is unavailable, we'll then move over to our secondary owners, our possible owners. So the virtual machine will still move there, it'll still come online, and as soon as one of my preferred owners is available again, we'll move it back to where we want to be. But this can ensure that the VMs can stay online on an ordered list of hosts that you want them to stay on. Now, we have this option to always start a virtual machine on a preferred host. And we want to do this because we realize that a lot of people try to optimize the placement of their virtual machines. We want this VM here, this VM here, this VM here. People do it to, most often to load balance the resources, distribute them across the fabric so that you have more or less equal network and disk I/O going through each of the different networking and storage fabrics. But what happens if, let's say I have a 4-node cluster. My first node crashes. Well, some of the VMs are going to fail over to the remaining 3 nodes. My second node crashes. Half of the VMs are going to stay to the remaining nodes. And then my last 2 nodes crash and my entire cluster goes offline. Well, the problem that we had, that we saw in 2008 is as soon as the first 2 nodes would come back online, all of those VMs would go to those first 2 nodes. They would flood those first 2 nodes, and oftentimes they would overwhelm them. First 2 nodes come online while they're waiting for node 3. They get flooded, they crash again. Cluster goes down. So what we built this feature for was to basically build a delay in when each of the VMs goes and starts on their respective nodes. So let's say I have a 4-node cluster, 10 VMs, 10 VMs, 10 VMs, 10 VMs. It all goes down. Well, as soon as the first node comes up, only the 10 VMs that were placed there will stay there. They're going to be persistent to that node. When the second node comes up, those 10 go there. Third node, those 10. Fourth node, those 10. And so this way, we avoid these startup storms and overwhelming our hosts. So the logical question, okay, let's say 3 are up, but node number 4 just doesn't come up. There's some permanent failure. What happens to those 10 virtual machines? Well, we actually have a timer built into the system. I believe it's set for 2 minutes, where those 10 VMs are going to wait for 2 minutes for this last host to come up. In that time, these other hosts, they get a chance to start up their virtual machines. After that timer expires, okay, we'll go put 3 here, 3 here, 4 here. So we continue to spread out the workload, and we don't overwhelm those hosts as they start up. Now, another question we get is, okay, I know how I can put a VM on a preferred host, but what if I want to actually separate my VMs across different hosts? And so we have a feature built into clustering. It's been around actually for several releases called Anti-Affinity Class Names, known as AACN. Now, directly through failover clustering, you configure this through PowerShell, but if you're using Virtual Machine Manager, there's a nice graphical user interface and a concept of availability groups where you can basically say, these 4 virtual machines, we're going to call them blue. They're going to purposely spread themselves out to as many hosts as possible. And so, when would you want to use this? Well, remember, our goal is to eliminate this single point of failure. There's been a few questions we've had about virtualizing domain controllers and putting them on a cluster. So let's say I have a cluster, but both of my domain controllers are sitting on one node. If I lose that node, it's a single point of failure, right? Both of my domain controllers are going down. I've lost that resiliency in my environment. So what we would then do, for those 2 domain controllers, we say, you're blue, and they will purposely spread themselves out to different hosts, so that you've got your domain controllers, you've got your hosts. If you lose one, you lose the other. The entire infrastructure still stays up and running. And you're going to want to use this for any type of infrastructure roles. You have DNS servers, DHCP servers. But also, you're going to want to use this if you use guest clustering. And remember, guest clustering, when we have all of our VMs running in the entire virtual layer. If I have a single host and I have all 4 guest cluster nodes on that host, lose that host, I lose my entire guest cluster. So once again, using anti-affinity, we can spread out our guest cluster nodes across different physical cluster nodes and still maintain the best levels of high availability. Now, we wanted to also make sure that we can monitor the VM itself. So we're not just looking at the physical server crashing. We want to check the health of this virtual machine. And so there's a setting available called the heartbeat monitoring of a virtual machine. This basically pings the VM, it says, are you healthy? And it checks that the virtual machine is responding. So if there's a user mode hang, a blue screen, we can detect it, we can restart that VM. But we wanted to go a step further in Windows Server 2012 and not just monitor the hardware, the servers, the virtual machines, but go inside the virtual machine and actually monitor the health of the services running within a VM. So let's say, for example, I have my print server, my print spooler service running inside the VM. We actually interact with Service Control Manager, and we see when that service crashes, we can take control over the actions of that service and that VM. We can restart the service, we can restart the entire VM, see if that helps, or we can even move that VM to a different node. So let's say there's a problem with the virtual network on this node, it's causing the service to crash. Boom, we detect that problem within the VM and move the VM to a healthy node with a healthy virtual network. Now, one of the biggest or most popular features in System Center Virtual Machine Manager was this concept of node maintenance mode. So let's say I have 100 virtual machines sitting on a host. I can do 4 live migrations at a time. Let's say 10 live migrations at a time, because we have that capability. Well, it's still going to take a while if you select 10, say go, select 10, say go, to actually fully evacuate this node when you want to do maintenance. And so what we wanted to do was just find a one-click option. What we can do is we can select a node, we can say we want to pause it, basically make sure nothing moves onto it, and also drain the roles. So this way, click, pause, drain roles, go get your coffee, go to bed, come back sometime later, and the host will be fully evacuated, ready for patching. And excuse me. And this leads us into the kind of final management topic I have here, which is cluster-aware updating. Actually, one of the more popular features which has come out in Windows Server 2012, because this used to be a nightmare for our cluster admins. So back in the day, with 16 node clusters, dozens of VMs on each node, to patch a host, you'd have to pause the node, manually live migrate one at a time through all of these VMs, apply a patch, reboot, see if there's dependent patches, maybe reboot again, take it out to maintenance mode, move all of those VMs back, and then go on to node 2. So we said, wow, this is painful. This is a repetitive task which could be automated. And it's only going to get worse in Windows Server 2012 as we scale up to 64 nodes, 1,000 VMs a host, 8,000 VMs a cluster. So we built this utility called Cluster-Aware Updating, which communicates through the Windows Update agent. So you can use wsus, Windows Update, basically download your patch, configure a baseline, meaning a cluster. It will go look at each of the nodes in the cluster, figure out which of the nodes need a patch, apply the patch, reboot, repeat. And as it goes through this process, it live migrates the VMs across all of these different nodes in the cluster. So you can literally, Friday night, start a patching cycle, come back Monday morning, every node in your cluster has been patched with zero downtime to the virtual machines as they have been live migrated. Now I'm quickly just going to show you how easy it is to go and deploy a virtual machine on top of a cluster. Now you can see I've already created my cluster shared volumes. So I'm going to go ahead and just create a new virtual machine. And this is actually, it starts with the exact same wizard that Jeff showed earlier when he created a virtual machine. But you're going to notice I'm doing everything through Failover Cluster Manager. And what we wanted to do was just simplify the administration. Instead of having to go to do some stuff in Hyper-V Manager, do some stuff in Failover Cluster Manager, if you're clustered, you can do everything straight through Failover Cluster Manager. Deploying your virtual machines, configuring the settings, whatever you need to do. And so what this is going to do is launch the new virtual machine wizard, the Hyper-V wizard. We get to give it a name, so let's call it VM Jumpstart. We get to select a location. But what's different now is when Jeff showed this demo on a standalone host, he used local storage here. What I'm going to be doing is selecting my cluster shared volume storage. So I'm going to go to my C drive. When you configure a disk for clustered shared storage, it automatically creates these volumes. Select a folder. I again get to specify things such as my startup memory, dynamic memory. I can connect it to my virtual network. I could create a hard disk now. I'll attach one later. Click Finish, and you're going to see this wizard wrap up, and suddenly a second wizard appears. This is the cluster wizard, which will then take that virtual machine you've just created and automatically go and place it in a cluster. So now here we can see my virtual machine. I have the ability to go and change the startup priority. If I went through the various properties, I could configure those preferred owners, those possible owners, and I could take a look at the settings, and this will launch the exact same management interface you have from Hyper-V. So I can go and configure everything, change my startup memory, do all those other nice things you want to do with a VM. Finally, we can click Start. Takes just a few seconds to start this one up since I don't have an operating system. And then for a live migration, as simple as saying move with a live migration to my best possible node. I'm currently on node 1. And we're going to switch off this live migration without really anything running in the memory. It will take about 30-45 seconds. And it's that simple to go and test a cluster, build a cluster, and deploy a highly available virtual machine on it. You can now literally do this in minutes. So Jeff, back over to you now.
Awesome, buddy. Kudos, Simon. That was fantastic. And so what you've seen there has all been doing configuring the clustering. Everything you've seen so far is, again, all using the inbox tools in Windows Server 2012. I should also mention, because I didn't see it asked yet, but I'm waiting for it to get asked, the clusterware updating you talked about, is that feature available for Microsoft Hyper-V Server? Come on, they wouldn't include that, would they? Why, yes, it is. That's also in the free Microsoft Hyper-V Server as well.
Excellent.
So, one of the questions we get asked is, we've just seen cluster deployment, and people realize, wow, look at all the enhancements that have happened with clustering. The fact that you can create 64 node clusters with 8,000 VMs, and people look at this, and generally what's interesting is people go to deploy their cloud. Very often I'll talk with an IT manager or a CIO or CTO, and they say, you know, Jeff, I hire really good people. I do background checks on them. They know these people. I trust these people. I'm not actually worried about the malicious admin. However, that's not what keeps me up at night. What I'm really worried is about the inadvertent data leakage. I'm worried about the whoops moment. And I kind of basically summed up that in this question that I get asked, which is, look, Jeff, I have good processes in place, but what other safeguards can I use to help protect my data? Let me give you a couple of examples of what I mean, some real-world examples. So, for example, some server hard disks appeared for sale on eBay. This is a real case from a U.S. power company. Now, being that it was a U.S. power company, it's under regulatory, a Department of Energy. This is a good company. They've been doing things the right way. They have strict processes in place. So what happens is, as they bring in new servers, their old servers are given to a third party that either physically destroys the drives or scrubs them to US DoD standards. They either degauss them, overwrite the data with a minimum of 3 specified patterns, but they actually have a third party dedicated to just disposing of their old servers while they take advantage of the new hardware. Well, in this case, what ended up happening was the data on these drives used in these servers contained proprietary information such as memos, correspondence, PCI, payment card industry information, confidential employee, and unfortunately, it just didn't go through the process. It wasn't a bad guy, it wasn't a malicious admin, it was simply a whoops moment. And these disks ended up being sold on eBay, and people were buying disks for $35, $40, and lo and behold, wow, I found a treasure trove of information. So this is a very real-world situation. It's something that, again, I find that keeps folks up at night. And according to Gartner, about 1/3 of companies use outside firms to dispose of their PCs and servers. So it's not like this is, something out of the realm of possibility or something that actually isn't relatively commonplace. One more example, this one to me hits a lot closer to home. This is a HIPAA breach. So this is a case this last year. In March 2012, a large medical provider was basically paying a $1.5 million fine to the U.S. Department of Health and Human Services. Now think about this for a second. What's the most private, personal, confidential data that you can think of? Wouldn't it be the health of you and your family and your children? Wouldn't you want to make sure that that stuff is completely protected? And in fact, that was the argument put forth by this company. But unfortunately, what happened was 57 hard drives that contained protected health information, EPHI, for over 1 million individuals leaked out. Think about that for just 1 second. Over 1 million individuals lost their most protected health information. Now the argument was, look, we secured this data. It was secured by security patrols. It was secured by biometric scanner. It was secured by key cards. It was secured by magnetic locks. It was secured by keyed locks. So, we've done a whole bunch of really good work to make sure we're protecting this information. And the response from the U.S. Department of Health and Human Services was, that's nice, but the data got out. And we've looked at this, and it's something we've been watching for years. And we really want to make sure that we're trying to do something to help improve this situation. And another statistic was 71% of healthcare organizations have suffered at least one data breach within the last year. If that doesn't give you pause, I don't know what else does. So we've looked at this problem very holistically, and we want to try and help solve this problem. To do that, we're introducing a critical safeguard for the cloud, which is encrypted cluster volumes. What we're using is we're taking advantage of BitLocker. And for the first time ever, we can now encrypt cluster volumes. Now let me be very clear. BitLocker is shipped for many years. It's actually shipped for a couple releases now, and it's fantastic. It helps us secure and encrypt the data on the disk. In fact, when our military goes out into foreign lands, all of their servers, they take them, they're encrypted with BitLocker. And standard operating procedure is, if I have to make a quick retreat, is to put a grenade on the server. If the grenade takes out the server, fantastic. If the grenade doesn't take out the server, that's okay, because if the bad guys pull out the server, the disk, the only thing they can do is type in the PIN or format the disk. Well, up to now, this has been limited to direct attached storage. So if you wanted to do this in a cluster, sorry, that didn't work. But now with 2012, this is simply included in the box. What this does is, first of all, it works with your cluster shared volumes. It works with your traditional disks. But this meant a lot of work between the failover clustering team, the Hyper-V team, Active Directory, because we wanted to make sure, of course, that all of this works together, group policy as well. And what this does is it gives us the ability now to create the biggest, baddest clusters in the industry, 64 nodes, 8,000 virtual machines, put it all on shared storage, and guess what? That shared storage is clustered. So in those two examples I gave, even if the disk gets out, someone plugs it in, like I said, you can only format it or type in the PIN. So we're helping protect that. The other question I get asked all the time is, what about performance? I'm assuming I'm going to take some massive performance hit, right? Well, we actually worked very carefully to make sure, number one, we were taking advantage of the latest performance enhancements we could do to get this level of encryption and make sure it was, we wanted to make sure it was a no-brainer for folks. And so we're seeing absolutely negligible performance impact, less than a percentage point. In fact, we had to do special instrumentation to actually find out what the performance impact was. It was less than 0.001%. So essentially, we're talking about encrypted cluster volumes for free. So we think this is an incredibly important capability that we included in Server 2012. So let's talk about cluster shared volumes. So cluster shared volumes are a capability that we've released it was in Server 2008, R2, and now we've taken it really to the next level in Server 2012. And really the whole point is, you've got multiple servers that need to read and write to virtual machines. They need to all see the same storage simultaneously, but you need to make sure that LUN ownership you can have multiple servers accessing the same server storage simultaneously. And cluster shared volumes allows you to do exactly that. Server 2012, we've made some huge improvements across the board. So let me give you a couple examples. One of them, this first one, improved interoperability with file system mini filter or intermediate filter drivers. Let me kind of explain what that means. Today, for example, if you want to do hardware-assisted snapshot, okay, say for example you want to take a snapshot on your SAN, the way it works is you'll have a SAN and your storage vendor will give you some drivers that get installed in the storage stack, and these are what we call intermediate storage filter drivers. Those get installed in the Windows storage stack, and so when you go to take a hardware snapshot, it's plugged into the storage stack and it coordinates it so it can take the snapshot with hardware. In Server 2008 R2, when we introduced cluster shared volumes, one of the things that we did at the time was, unfortunately, intermediate filter drivers didn't work out of the box with cluster shared volumes. So if you wanted to take a hardware snapshot and you were using cluster shared volumes, we actually went to our storage vendors and said, hey guys, we need you to tweak your drivers a little bit, make a couple of modifications. The other one was for asynchronous synchronous replication. So if you're doing SAN replication between two sites, the way you do SAN replication is, again, there's an intermediate storage filter driver that gets installed in the storage stack, and that plugs right in to do the replication from one SAN to another. So if you're doing DR with two SANs, that's how they plug in. Well, again, unfortunately, with Server 2008 R2, intermediate storage filter drivers didn't work without modification. Again, we work with our partners, but they weren't really keen to making those changes since it just automatically worked in the past. In Server 2012, this is no longer an issue. The cluster team did a fantastic job, made some changes to how cluster shared volumes work. The upshot of it is your intermediate storage filter drivers just work now. So if you want to take a hardware snapshot, it just works. You want to do synchronous replication from site 1 to site 2, it just works. If you want to set up a cluster in one location and set up a cluster in another location and take advantage of replication and doing stretch clusters across geographic distances, it all just works. The other key benefit is backup software. So in cluster shared volumes in the past, say you had an 8-node cluster and you were using cluster shared volumes and you needed to do a backup. What would happen is you had to back up each node serially. So you back up node 1, back up node 2, back up node 3, because otherwise you'd go into a redirected mode. Not any longer in Server 2012. This is a really important point. If you're using Server 2012, you no longer go into redirected mode for backup. You can have a 64-node cluster, do 64-node parallel high-speed backup with cluster shared volumes. Done. So now we've got this tremendous backup capability, and in fact, good luck ever seeing cases where we go into redirected mode. Server 2012 cluster shared volumes, it's almost never going to go into redirected mode. So we've done some tremendous work there. Integrated with new file system features. For example, I mentioned offloaded data transfer earlier on. Talked about BitLocker encryption, and again, all of this works with Active Directory. The other thing to point out is the work that we did to make Active Directory work on top of a failover cluster in a VM. So now for the first time ever, if you want to run a domain controller in a virtual machine, that virtual machine is running on a failover cluster. In the past, when failover clustering comes up, it's looking for the domain controller. Well, if the domain controller is in a VM and it's not up yet, you're going to have a chicken and egg problem. Well, guess what? We solved that one as well. So now you can safely run domain controllers in a VM. You can run all of your virtualized workloads on top of Hyper-V, on top of a failover cluster, and it all just works. So a couple thoughts about VM mobility, and again, these come from you. One of the things that we heard, time and time again was don't provide new features that preclude live migration. And again, my favorite example would be, I would ask a customer, I would say, look, here's a brand new feature, feature X. I can give you feature X, but if I give you feature X, it means this virtual machine is locked to this piece of hardware. Can't live migrate, can't storage migrate, can't cluster. It is literally locked to this piece of hardware. And the answer was always the same. We just don't even want to talk about this feature to take this thing away, because live migration is absolutely paramount for us. We want to be able to do exactly that. In fact, customers would almost always say, would we push it a step further? They would say, you know what? We want you to make it even easier. In fact, what we really want to be able to do is move a VM or any part of a VM anywhere at any time without any limits. That is a huge engineering challenge. Let me say that one more time. I want to be able to securely move any part of a VM anywhere at any time, no limits. That is a big, big challenge, and I'll get to that in just a second. I want no downtime servicing. So for my SANs, for my upgrades, for migrations, people tell me I've got a SAN lease. This lease is coming up. I'm going to bring in a new SAN, but I want to be able to migrate those workloads from my old SAN to my new SAN. Or I want to be able to bring in a file server, bring in the new Windows Server 2012 file server, and maybe I can move some workloads, live migrate them to some of my file servers at a much lower cost, take advantage of storage spaces, thin provisioning, deduplication, move those things off, and really try and take advantage of that lower cost storage. And also, when my VMs migrate, make sure, of course, all the historical data moves with it, and fully leverage the hardware to speed migrations. So again, if I've made the investment in multiple gigabit NICs or offloaded data transfer ODX, or if I'm using multiple 10 gigabit NICs, whatever I'm using, just please tell me you're taking it to the absolute limit and fully leveraging that hardware. So there are a number of things we did. Number one, we talked about this a couple times, which is live migration queuing. So now for the first time ever, you can say, look, I have 50 VMs I'm going to live migrate. But you know what? I'm on a really slow link. I'm on a gigabit, so maybe I'm going to do 2 at a time. Okay, so it'll do 2 at a time, but it'll just queue them, and it'll just keep right on going. And that's using inbox tools to queue and manage large numbers of VMs, or you could do this with VMM as well, but live migration queuing. Also, you can do concurrent live migrations, as I mentioned before. It's only limited by how much hardware you want to provide. Are you going to use a single gigabit NIC? Are you going to use two 1 gig NICs team? Or are you going to use two 10 gig NICs team? You tell me what you want to provide. We can live migrate crazy amounts of VMs, but it really depends on the hardware you want to bring to the party. So how does live migration work? Well, very quickly, the way live migration works is it happens in a couple of stages. So first I've got my source and I've got my target. The first thing we do is, first of all, when you initiate a live migration, it can happen through Hyper-V Manager, it can happen through failover clustering, or it can happen through PowerShell, it can happen through VMM. But essentially what happens is, in the case of a live migration, I'm talking about a traditional live migration with shared storage like a SAN, what happens is the virtual disk is living here on the SAN. So I've got my virtual disk living here on the SAN, and what happens is the VM itself, the active running state, the CPU state, the memory state is running here on the server. And what I want to do is live migrate it from server 1 to server 2. So what happens is the first thing we do is we do a pre-flight check. We make sure that, okay, I'm going to live migrate over here. Are there enough resources? Is there enough memory? Is there enough CPU? Can I do this safely? Does it have, does it have a compatible processor? If not, do I have processor compatibility mode enabled? Okay, great. All of these things check out. Then let's start live migrating the VM. So the way this works is when you start to live migrate a VM, let's assume a virtual machine has 4 gigs of memory assigned to it. Well, of that 4 gigabytes of memory, it's very likely that only a very small portion of it is actually active. Maybe of that 4 gigabytes, maybe 50 megabytes or 100 megabytes are actually active. So what we do is we create a new virtual machine on the target. We make sure it's got the same exact configuration, same number of procs, storage, everything's configured, all the resources are allocated, and then we start copying all of that live state over the network. And what we're trying to do is we're taking it from 4 gigabytes to that small running state. So really, if there's 4 gigabytes allocated to the VM, but really only 50 to 100 megabytes is actually used, I can safely copy over 3.9 gigabytes. All of this is happening over the network. Now, of course, while this is happening, the VM is still running. So it's changing state, things are happening, maybe people are connecting to it, and what we call this process, we're tracking dirty pages. So pages in memory will change, and of course we're tracking every single one of those, and we make sure those get migrated across. Finally, what we do is we get the running state down to we get the full memory contents of the virtual machine down to a very minimal running state, and then do a quick brownout, and then we can do that without even dropping a ping. And so what happens is your session state is maintained. I can be streaming videos off this, I can be copying files to it, I can be pinging it, and I will live migrate it to another server without dropping any of those things. And so that's pretty much how live migration works in Server 2008 R2, how it works in 2012. Now, in that example, I was using a SAN. Well, what's new in 2012 is now we can use a file server. And in fact, what's interesting about this is by using the file server, clustering becomes optional. So for example, if you're in a test dev environment, you may want to set up live migration. You may want to live migrate VMs between different machines, but maybe you don't care about high availability. Look, it's test dev. I don't care if the machine goes down. I don't care if somebody shuts it down inadvertently. It's a test dev environment. But I still would like the mobility aspect. So what happens is with SMB, you can put your VMs up on file-based storage. You can live migrate the VMs around without even enabling clustering. If you decide later that, I do want high availability, I do want that clustering capability, great. Go enable clustering just like you saw Symon do. Go through the validation wizard, make sure everything's there, and now you've got a solution for HA for planned and unplanned downtime. But with SMB, clustering becomes optional. So this is a huge win. Well, again, I'm going to go back to your requirements. And really that really tricky one, which is you said you wanted to be able to move VMs anywhere at any time without any limits. So it's that without any limits that's the real challenge here. Because if you look how we've done live migration in the past, it's always been using shared storage. Okay, I've got 2 servers, but I've got storage here, and the VM disks actually reside on the shared storage, and you're moving the live connectivity. Customers, you basically have said we want complete mobility. I would like to be able to live migrate between 2 servers without any shared storage. Okay? This is long considered the holy grail of live migration. People have been trying to solve this one for quite a while, and quite honestly, it's been a huge challenge. But guess what? We were up to the challenge because that's what you wanted. So in Server 2012, we've introduced Shared Nothing Live Migration, the first to bring Shared Nothing Live Migration to the market, and it's a key capability simply built into Windows Server 2012, and I'll go ahead and anticipate your next question. It's also built into the free Microsoft Hyper-V Server 2012. Now, Shared Nothing Live Migration doesn't require any shared storage. There's no SAN. There's no clustering. There's no file server. It's literally 2 systems with nothing but an Ethernet cable. Now, I want to be very clear about something. Shared Nothing Live Migration is not HA. I've always been very transparent about this. It's not a high availability solution. Okay? If I walk up to a server and yank out the power cable, that VM's down. because you didn't configure clustering. If you want a solution, a high availability solution, configure clustering. However, with shared nothing live migration, what it does is it provides these enormous benefits. And those benefits are around portability and mobility. So for example, now with shared nothing live migration, it solves some key challenges that people have run into. For example, what happens when you've got a cluster that's full? Well, you go set up another cluster and put more VMs on. Okay, great. So what happens when you want to take those VMs from cluster 1 and move those to your brand new cluster 2? Well, up until now, it's like, well, I've got to take these VMs offline. I've got to turn them off. I've got to copy them over here because there's no shared storage between those two. Got to bring it up over here, and it's this, convoluted kind of thing to move between. With shared nothing live migration, we don't require shared storage. So now for the first time, I can live migrate into a cluster. I can live migrate out of a cluster. I can live migrate between clusters because there's no shared storage requirement. In fact, let me show you how to do shared nothing live migration. And again, I'm going to go back to my office here. I'm going to go back to two desktop machines sitting in my office that have literally nothing but an Ethernet cable between the two. So in this case, I'm going to go ahead and right-click on a VM, and I'm going to click on Move. And the first thing I want to show you is we've got a number of different move types. We can move the virtual machine, which is the equivalent of shared nothing live migration, or I can move the virtual machine storage. That's live storage migration. So what's nice about this is, I have this running on one of my servers, but what happens if I run out of even local storage? Well, I could plug in another USB disk, I could plug in some additional locally attached storage and migrate just the storage over, keep it running on the same server, but it helps me when I'm running out of disk. Now in my case, I want to move the entire virtual machine. I'm going to move the VM and its storage to another computer. So I'm going to click on Next. It's going to ask me, give me the name. So I'm running currently on, whoops, I should come over here. I'm running on Beta 1, and so I'm going to move this on over to Alpha 1. Now, a couple of different options here, and there's a lot of level of granularity we provide here. So I want to move the entire VM, so I can move the VM's data to a single location. This means any snapshots, any differencing disks, and the entire virtual machine, its config files, everything, all of the on-disk representation, as well as the in-state, all of the CPU, everything's going to move to the new location. Or if I wanted, I could be very granular about it. Supposing I had a VM that had, 4 different disks attached to it. What if I wanted to move disk 1 to a file server, disk 2 to a SAN, disk 3 to a different volume, disk 4 to another different volume? You could actually have live migration to 4 different targets simultaneously. That's how granular we got. Because again, we listened to your requirements, and your requirements were all about being able to provide this level of migration. And then of course I could move only the virtual machine, which is just moving the configuration file. It actually would leave the virtual disks here on this local machine and just move the configuration file. So I'm going to move everything, okay? And I click Next. Now it's going to ask me, where are you going to put this? Well, I've got this brand new storage space that I'm running here. This is a Platinum space that I'm running, a storage space. I'm going to put it in this folder, and I'm going to click on Next. So just like that, you can see I've configured shared nothing live migration. Now again, I'm talking about 2 servers in my office. I keep saying servers. 2 desktop machines. These are towers. They have 8 gigabytes of memory. There's nothing special about these. They're attached to one of those little white switches. It's a gigabit switch. There's no teaming. There's nothing literally happening here. And I'm going to click Finish. And now we're going to begin shared nothing live migration. Oh, actually, it's going to warn me first. It's going to say, you know what? Your switches aren't configured. Can you help me with that? So as part of live migration, I mentioned before, we do a pre-flight. We go to make sure that all of the resources are there. Well, it turns out, and in fact, I forgot I'd done this on purpose because I wanted to show you this, is I actually created a virtual switch on server 1 and a virtual switch on server 2 that have different names, so they don't match. In the past, you'd get an error and you'd have to go fix this. In Server 2012, you get an error, and in fact, we bring this up and we tell you, hey, would you like to go configure the virtual switch? And in fact, that's what I'd like to do. I'm going to click Next, and now I'm going to click Finish. And now what you see happening is literally I'm performing shared nothing live migration, live migrating a VM from one server to another without any downtime. This is all over the network. So how does this work? So let me explain shared nothing live migration while it's happening here. So in shared nothing live migration, we're basically taking advantage of multiple migration technologies and techniques to do all of this without any downtime. The first thing we do is we actually perform the storage migration first. In fact, it's already done. Here I am on Jeff Alpha 1. There's the server I just moved, server 2008 R2, and there it is right there. So again, let me get to explaining how this all works. With shared nothing live migration, basically what we do is we do the live storage migration first. So what happens is we look at all the on-disk representations, virtual disks, snapshots, etc., and we copy those over first. We then put the virtual machine in what we call an I/O mirroring mode, where we're basically mirroring all writes to both locations. Now the reason why we need to do this, of course, is we need to make sure that if anything happens in the middle of a migration, that your data is always safe and protected. If I walk up to a server and in the middle of this I go, cut the Ethernet cable, I want to make sure that your machine is continuing to go on the source. Okay, the target it's not the migration is going to fail and nothing's going to happen on the target, but I want to make sure that the source continues right along. So what happens is we put it into an I/O mirroring mode where writes are happening to both locations. Once we do that, then we start moving all of the virtual machine state, all of the memory state, all of the CPU. That happens all over. Once that makes it across the network, and then we can begin executing on the destination. We then begin executing on the destination, and we delete it on the source, and that's how we've done shared nothing live migration. So I've just taken an incredibly difficult engineering technique and technology, and I kind of summed it up in about 60 seconds. But that's how shared nothing live migration works. Very awesome capability, and again, something that's simply built into Server 2012.
So we had a few questions about, some of the features as part of this set. So maybe some of the limitations here. So can you do this shared nothing live migration to computers that are the same architecture, but just different, different actual servers?
Great question. So this is where you take advantage of that feature we talked about earlier, which is processor compatibility mode. One of the things I like to test is I do have different machines with different processors in my office. A couple of them are Core i7s, a couple of them are Core 2 Duos. I used to have a Pentium 4 VT. I finally retired that one. But I've got a bunch of different processors, bunch of different systems with a bunch of different processor types, so I can test and do processor compatibility, do shared nothing live migration across different systems with different processors. So as long as you enable the processor compatibility mode, what we do is we essentially normalize the virtual processor that we present in the VM. And so what this does is it means that I can safely move a VM across different, from one server to one system to another that have disparate physical processors. For example, with processor compatibility mode, I can literally live migrate a VM from a Pentium 4 VT released back in 2005 to a Sandy Bridge running today in 2013. You're talking an 8-year span in servers, and yet I can still do that with processor compatibility mode and live migration.
So what happens if on my first host and my second host I have different sets of virtual networks? Mm-hmm. How does that get figured out? So
like I was showing you here, one of the things we do now is we'll prompt you. When you go to do a live migration is, again, we do a pre-flight, and one of the things we'll check out is the networks. And if the networks match, then great. You've configured them all with similar names and everything matches, we'll do that. If you didn't configure them, like for example, I configured one with CorpNet and I configured my other server that didn't have one called CorpNet, it flagged that and said, whoa, hold on here. Or would you like to attach this to a network before we do the move, which is exactly what I did. And of course, if I had multiple NICs with multiple networks, it would flag me for each virtual network to make sure all of those were correct. So extremely powerful shared nothing live migration. So I've already talked about live migration. I've talked about live migration with file shares and SMB now. I've talked about shared nothing live migration. I've talked about storage migration. I'm already way over time, but I have got to get to probably one of the hottest, if not most requested capabilities, I think that shocked a lot of people, which is Hyper-V Replica. And I can, for me, it's easy for me to kind of sum up what was on my mind in this picture. So what you're looking at is Hurricane Katrina, August 28th, 2005. This is the largest natural disaster in U.S. history. I know we're still recovering from Sandy, and we will be for a very long time. So we haven't fully figured out what the cost was in terms of Sandy. But up to now, Hurricane Katrina was a $110 billion disaster in U.S. history, the largest natural disaster in U.S. history. Over 80,000 businesses were heavily impacted or destroyed. Over 1,000 people lost their lives. There are people today in New Orleans and in the Gulf Coast that today, right now, are still rebuilding from Hurricane Katrina, and it's 2013. So this has had a profound impact. And honestly, I'll never forget looking at Hurricane Katrina in both, awe and shock as this thing really, we watched it for 7 days. I grew up in California. In California, we have earthquakes. There's not much you can do when an earthquake happens, okay? You don't get a warning, okay? And an earthquake just happens. But here's the case with a hurricane where literally we saw it coming for 7 days. Think about this for just a second. If someone said to you, hey, by the way, your house is going to burn down in 7 days, you're going to sit back and let it burn down? I don't think so. But that's exactly what happened in the case of Hurricane Katrina. We knew it was coming. We watched it. We said, yep, here it is. It's coming around. Yep, it's entering the Gulf Coast. Yeah, it's going into the Gulf of Mexico. Yes, it looks like it's heading right towards Louisiana. It looks like it's going to make landfall here. It looks like it's going to hit New Orleans. Yeah, it sure did. We watched it for 7 days. And it really brings up a lot of questions. Disaster recovery technology has been around for a long time. This is not new technology. This isn't something that just appeared yesterday. DR technology has been around for many decades, and the question many of us have been asking ourselves is, well, why aren't people deploying this? Why aren't people using it? Why didn't more people save their businesses even with a full week's notice? It's because there are some huge challenges when it comes to DR. Number one, cost. If you've ever set up DR, I'm going to paint with a broad brush for just a moment here, but if you've ever set up DR, generally what it means is you've got site 1 and you've got site 2. Here I'm going to set up a big SAN, here I'm going to set up a big SAN, and I'm going to set up some big replication pipes, and I'm going to replicate from site 1 to site 2. Okay? Now, great. That's really expensive. Cost is a real challenge here. Number 2, complexity. Let's just take one aspect of DR, networking. Okay? Over here on networking, I'm running on a 192 subnet, and I need to fail over to a 10 subnet. How do I do that? How do I make sure that all those workloads are going to come up here in this new environment and know how to deal with this situation? Number 3, inflexibility. Like I mentioned earlier, generally we're talking about SAN to SAN. Well, what if I have branch offices? Am I going to put a SAN in every branch office? Generally, the answer is going to be no. Okay, so what we need to be able to do is, how can we provide it to more storage targets and more storage options? Initial replication. What if that first replication is 40 gigabytes, 60 gigabytes, 100 gigabytes? Oh, and by the way, the pipes that I have are pretty small. Finally, what about distance requirements? What if I want to replicate, not just from, say, Redmond to Seattle or Seattle to Tacoma? What if I want to go from Seattle to Dallas or Seattle to Chicago or Seattle to, I don't know, Hyderabad, India? Well, you're not going to do that with synchronous replication. So we looked at these challenges and we said, we want to provide a solution in the box with Hyper-V Replica. With Hyper-V Replica, we provide asynchronous, application-consistent VM replication in the box, period. This is a feature that's built into Server 2012. This isn't some additional add-on. The capabilities here are built right into the platform. Number 1, it's built right in, so there's no additional cost. Number 2, it works with all of your storage. Doesn't require a SAN, doesn't require a file server. You could literally have 2 servers with direct attached storage that are replicating between each other. Okay? I can go from now a branch office with direct attached to a file server. I can go from a file server to a SAN. I can go from, you name it. You can mix and match your storage. In addition, we made sure that this all integrates with Hyper-V. So this integrates with live migration. It integrates with failover clustering. So even as you live migrate VMs around, your VMs are failover clustering, they're still being replicated. Also, this is application consistent. So we take advantage of volume shadow services to provide VSS consistent application snapshots that are being replicated from site 1 to site 2. Let me be very transparent about this. Our goal is we want to help you protect your data. Very clearly, very simply. Okay? That's why we made it this easy. And in fact, I know I'm way over time, but I'm still going to do the demo. So I'm going to switch on over here, and I'm going to actually bring up Replica. I've got a VM that I'm running right here. Well, let's walk through replication with Hyper-V Replica. I'm going to right-click on Enable Replication. First thing it's going to ask me is, where do you want to replicate it to? I'm going to replicate it to Jeffu Alpha 1. Click Next. Now it's going to ask me, how do you want to authenticate that replication? Now, I can use Kerberos, HTTP. Now, you can see very clearly we'll tell you data will not be encrypted while being transmitted over the network. If you own both ends of the pipe, then great. Kerberos could be perfect for you. But if you want to do this over the wire, over the internet, over the WAN, then you're going to want to use certificate-based authentication. Maybe you want to go from one site to another. Maybe you want to go to a service provider. Maybe you're a service provider that wants to provide replication, a target replication site. You can do all of that with Hyper-V Replica. In addition, you'll notice that we have compression. Compression is included and it's on by default. We see on average anywhere from 40 to 60% compression savings with compression in Hyper-V Replica. And the point here is we want to make sure we use your network resources most efficiently. So I'm going to go ahead and stick with the defaults here. Next, it's going to ask me, which disks do you want to replicate? Now, funny thing, people look at this and they go, well, why wouldn't you replicate some disks? Why wouldn't you always replicate a disk? Well, let me tell you exactly why. You can see here I've got a virtual machine. It's got 3 disks. It's got the OS boot file, OS boot disk. It's got the second disk, which is just the page file. And I've got a third disk, which has my data. Okay? Well, the reason why I did this, I actually have a boot disk, a paging disk, and my data disk. And the reason why is because people have said, in some cases, if I'm replicating, why do I need to replicate the page file? You don't. In fact, you can uncheck it right here, because if I'm going to replicate it, I'm going to start it up. When I start it up, it's going to recreate the page file over there. So if the page file is something that's consistently churning, and I'm on very tight links, this is a great solution to help you there. So I'm in fact going to keep that unchecked, and I'm going to click Next. Now, how many recovery points would you like to keep? We can keep by default only the latest one, or maybe you decide you'd like to keep the last 4. Look at this number right here. This tells me how much disk storage I'm going to need for additional snapshots. Well, guess what? Maybe I don't need 4, maybe I want 8. Okay, well, we automatically recalculate. In fact, you're going to need more space. Or you know what? Let's do 15 of these. So we give you the flexibility to determine how many recovery points you want to keep, and let you know just how much storage space you're going to want. Finally, if you want to use volume shadow services, for example, you're using a workload that's VSS aware, like SQL, for example, or a file server, for example, then we'll actually take a VSS snapshot. What happens is we call down into the guest operating system. We tell the guest operating system, please get yourself properly flush everything to disk, properly quiesce everything, and we're going to take a snapshot. And then that ensures we have an application consistent snapshot. I'm going to go back to default. I'm actually only going to keep the latest recovery point and click Next. Now, that initial replication can be a challenge. Like I said before, if that first replication is 40, 60 gigabytes, and I'm doing this over some pretty thin pipes, how's this going to work? Is this going to take me days or weeks or months? Well, it could. So one of the things we wanted to do is certainly we can send the initial copy over the network. We can copy using external media. For example, we could burn it to a DVD, put it on a USB disk, and FedEx it to my recovery site, and then we only have to catch up with the diffs. So we thought of that as well. And finally, we could also schedule the replication. So that initial replication, right now it's the middle of the day here at Microsoft. Do I really want to start this right now? Or in fact, would I like to maybe start it on a Friday at, let's start at, I don't know, maybe 11 p.m. when everybody's left the office. And guess what? Now I have all of the network connectivity available to me, and it'll start Friday, it'll run all weekend long, and this is great. So I can begin and schedule that replication. I'm going to go ahead and start my replication immediately. I'm going to do it over the network. I'm going to click Next, and you can see there's a summary of what I'm going to do, and I'm going to click Finish. And like this, I'm going to begin enabling replication. And it's going to begin replicating from one site to the next. Now, one thing you may be thinking about, I mentioned this earlier, is what about things like networking? How do I deal with the challenge of, hey, I was running on site 1 that had one set of IP addresses, and I have another set of IP addresses when I move to my new subnet? So there's 2 ways you can solve this. If you want to use our software-defined networking, use network virtualization, create a flat network, guess what? When it fails over and replicates to the new site and it comes up, guess what? It's going to keep the same IP address because you created this big flat network. However, if you haven't used software-defined networking, we've thought of that as well. So let's come in here to Hyper-V Replica, and you'll notice it asks you as you configure Replica to go in here and go here to your network settings, and lo and behold, there's failover settings. So what we've done here is we add this new setting into the NIC when you do replica. So this VM is being replicated. So now what I can do is I can type in a specific IP address. You know what? This is going to come up on 10.0. 25. I can type in a subnet mask, default gateway, preferred DNS, etc. I could do this for IPv4 and IPv6. So what happens in this case is, in the case of replication, in the case of failover, so guess what? Site 1 is burned down. Site 1 no longer exists. Now we're going to bring up Site 2. When we do that, Hyper-V Replica will automatically inject these IP address settings into the VM at replication. So we've thought of that as well. So when you bring it up on the new site, guess what? The IP addresses are ready to go, and that's simply part and parcel of configuring and enabling replica. So in addition, we also have test failover. So if you want to be able to set up Hyper-V Replica and you want to actually test failover without actually performing it, you can do that as well. By the way, this replication, it's just about done. Now, before anybody starts wondering, well, that was really quick, these are in my office. Okay, these are two machines sitting next to each other. So this is happening over, over that little white gigabit switch I was telling you about earlier. Now, question I get asked all the time is, Jeff, what are the hardware requirements? Again, do I need a SAN? Do I need file server? Any of that? No. If you want to replicate between two servers that have nothing but direct attached storage, you can do it. In fact, that's what I just showed you. Those are two servers with nothing but direct attached storage. No SANs, no file servers, nothing. Literally standing with built-in internal disks. That's it. In addition, what about the networking requirements? I always get these questions. What are the requirements? Well, our goal for Replica was to work with commercially available broadband. Okay, if this thing needed dark fiber, we're not interested in that. Those solutions already exist out there. So our goal is to go after, really low throughput, high latency. We know it's going to be out there. And even if your network can't keep up, one of the things I get asked all the time is, what if I'm in an office? I'm in a small office, and throughout the day the network is busy and Replica can't keep up. What's going to happen? Well, it's all log-based. Okay, so we're keeping track of all the changes that are happening, and guess what? As everybody leaves at 5, 6 o'clock, guess what? Replica will then catch up overnight. Okay, as the network congestion frees up, we're going to catch up, and Replica is just going to continue right along, because that's how DR works. So I know we've gone way over time in this one. Couple things as we finish up. I talked about Hurricane Katrina, I talked about Replica, and one thing I'm very happy to say, I'm glad to say that Replica has already been working and has already saved customers in action. Because here is Hurricane Sandy. This is a NASA image. This is it basically hit the East Coast and walloped everyone in Hurricane Sandy. And I'm thrilled to say this is an email that hit my inbox on the day of October 30th. Basically, good morning. The hurricane hit our area badly, many downed trees, even on my wife's car. Flooding and total power cuts were everywhere. We are grateful that everyone is well. I now want to thank the Microsoft 2012 server team for giving business the new Replica feature. Two of our clients, both of whom cannot be without their IT infrastructure, were flooded entirely and might take 2 weeks to get back into their businesses. At 7 p.m. last night, we failed over the entire domains to the Replica site and then been able to continue their daily business with 0 interruption. Windows Server 2012 saved their business. That's exactly why we built it. Thank you very much, and we really hope that you do take advantage of it. So with that, remember, it's easy to set up. It's built in. You can walk through a wizard just like I did it. You can use PowerShell. It works with your existing hardware. It works with your current hardware. All you need are a couple of servers running Windows Server 2012, and there are no guest dependencies. I could have done that, by the way, with Linux. I could have done that with any OS because it's transparent to the operating system in there. So with that in mind, Simon, I think we're way over time.
We are. I'm going to wrap it up by just saying one more thing about Hyper-V Replica, because we haven't talked about clusters with the Hyper-V Replica.
Oh my goodness, yes.
And I've had quite a few questions here. How does replication happen with a cluster? Does this kind of change our traditional replication model in a multi-site environment? So the way replication works with a cluster is there's actually a brand new cluster role that you can deploy that's highly available, moves between the different roles, between the different nodes, called the Hyper-V Replica Broker. And basically, it's a clustered service. One node goes down, the replication engine moves to another node, so there's always a single replication engine. And so it's highly available, and it will replicate if you have two different sites from cluster 1 over to cluster 2. So an important thing, you can replicate from a cluster to standalone, standalone to cluster, cluster to cluster, but you cannot replicate within a cluster. So if you have node 1 and node 2, since there's only a single Hyper-V Replica broker, these two nodes don't replicate to each other. So you go ahead and you create two separate Hyper-V clusters with 2 Hyper-V Replica brokers at each side, and you are up and running with a completely free in-box replication solution. And on that,
actually, one last thing,
one more.
Going to get
What's
asked.
in here?
Is Hyper-V Replica in the free Microsoft Hyper-V server? Yes, it is.
Yes, it is.
On that, let's take a break.
All right, we'll be back in 10 minutes. Thanks, guys.